Welcome back, students. This video we're going to cover lesson 5-3. This is proven triangles congruent, SSS and SAS. Got three standards for this particular topic. GR 1.2, 1.3, 1.6 listed there. So let's see. We'll get right into it. So first we're going to talk about side, 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 which is SSS congruence postulate. Excuse me. So if three sides of one triangle are congruent to three sides of a second triangle, then those triangles are congruent. So our example over here to the right, triangle ABC is congruent to triangle XYZ by SSS, or side. So these two sides, these two sides, and these two sides. So a triangle has six corresponding parts, three angles, three sides. So 3 plus 3 is 6. In order to prove two triangles congruent, we need 3 of 6. So here we have 3 sides. And then down here we're going to talk about side, angle, side. So we have 2 sides and the included angle. So if you see a side and a side, the angle that is made from these 2 sides. So that's why it's the included angle. So over here, ABC is congruent to DEF by side, angle, side. So side, angle, side. The angle's in between, and it's on the triangle just as it's written. So, but two sides and the included angle of one triangle, 2 sides and the included angle of the second triangle, and then those triangles are congruent. So again, three of the 6 corresponding parts. I like to, we've got one arc. If we had a second angle, it'd be a second arc, and third, just like here, it's a slash mark in the side. I like to use different colors. It makes it easier to see. Hopefully it all comes in. It's very strange as I make the video because on the screen it kind of looks, they don't look as colorful as here in real life. But anyway, so let's get on to example 1. All right, so we have a proof. Let's see, give me 1 second. All right, so they want us to prove that triangle QRT, so QRT is congruent to SRT. See, they're made from the one big triangle, and this splits this in half. Of course, if we're splitting one big triangle into 2 halves, that should tell us they're congruent, and it does. But in this class we have to break it down, and we'll do that. So our given is that QRS, so that's the whole triangle, is isosceles. And by that being an isosceles triangle, these 2 sides are going to be congruent. I'm just going to do it with this, though. And it tells us QR is congruent to SR. All right, so next statement, I'm just going to grab the next color because I know what's coming. RT, so this guy, bisects QS at point T. So remember, bisect means we're cut into 2 equal pieces. So that puts this guy congruent to this guy because it splits that line in half. And this is going to come in probably somewhere around down here. But labeling this kind of helps you answer your questions before you even read them. At least that's what I'm hoping to get you guys into doing. Okay, so first box. Grabbing my red pen. So QRS is isosceles with QR being congruent to SR. Given. Check. All right. So that leads down here, but we've got to cover all our bases. All right. So RT, ray RT bisects QS. Ray RT bisects QS at point T. So that was our other given. Over here, We have a blank. Now we have no word bank, but I'm hoping we can do without it, especially when we've only got two little things to come up with. And we've already kind of got some clues. So for A, so we'll write it here, but we'll write it bigger here. So the reason they give us is reflexive. So before we look at the figure, reflexive, let's think about what does that mean? Well, we've talked in class about when I look in the mirror, I see my reflection. So when I look in the mirror, I'm the same height in the mirror as I am in, on the other side of the mirror. Or my width, I'm just as big on one side of the mirror as I am on the other, sadly. But that's, the mirror can't lie. Anyway, enough about the mirror. So you see RT, it's congruent to itself. Now, it belongs to both of these triangles, so we need to include it. Let me use a better color. Let's just use, we got 1, 2, 3. So what you would write is RT is congruent to RT because it's reflexive. All right, so let's go here. Now we've got QT is congruent to ST, and that's because the definition of a segment bisector. So it cut its segment in half, or in two equal pieces, so that's how we know they're congruent. So all this leads down here to one triangle, so QRT being congruent to SRT. Why? Because a side, and a side, or SSS. So let's write it bigger here. RT and SSS. So A was RT is congruent to RT. B was SSS, or side. Before I turn you loose over here on the you do, or the example 1 check, notice, so they tell us QRT, SRT. So QRT, SRT. So QR is blue, 1 slash SR, same thing. And then let's see, from RT, what was the point I was getting at? Dang it. We have to name it back correctly. That's what makes it's congruent when it's named this way. If we named it a different way and you had, like, say it was TQR on this side, which made your purple go first, and it was RST on this side, your single or blue congruent mark over here, it wouldn't be corresponding parts. I know I went a little off in left field there, but I just wanted to point out, just like up here, it's the same. The blue, this green matches up. And you're like, well, Mr. Whitlock, you put those colors. Well, the marks, they're colored that way because of this is 1, this is 1, this is 2, this is 2. And I'm pointing off the screen and not even, sorry. 1, 1, 2, 2, 3 to 3. That, just pointing out again the corresponding parts. Sorry. It's late and got off on my soapbox. Okay. So, example 1 check. Missing a picture, so I drew it in here for you. And because of that, I'm just going to kind of mark our given and turn you loose. You have 2 blanks here. Since we don't have a word bank, I'm going to at least fill in the one side. I hope you guys, I can get you far enough. So, given AB is congruent to AD. So AB, AD. So we mark those. All right, BC is congruent to DC. So BC to DC. Okay. Yeah, that looked, let me see if I can, there, that's a little better. Okay. So, and they want to prove that triangle ABC is congruent to triangle ADC. So, your blanks here. We'll fill this in. Your reason is reflexive. So I hope with the information you have here, you can figure out what you're using the reflexive property to prove. And then when the two triangles, how are they congruent? We already have two sides. So there you go. All right. Going down here, and I've already started this because I'm trying to watch our time on our video. Let me just make this a little bit darker. All right, so example 2, triangle JKL. That is this guy. So this is J. It's hard to see the letters. K. No, K's over here. My bad. And L. All right, now you know I left the letters off. Okay. Triangle QNP. This is this, and I'm not going to write the letters because we're going to have to move from here to here, and you need to be able to see because it's not a one movement thing; it's a two movement. So they give us the vertices. Like I said, I've already graphed them. That was part A. If you need help graphing, reach out to me. Also look back module 4. There's a lot of graphing, and I take time to, maybe in the last video, to kind of go over, remember your X coordinate is left, right. Your Y is your up and down. Positive is right. Negative is left. Positive is up. Negative is down. So anyway, these are both graphed. It says make a conjecture and support your conjecture. The conjecture is going to be that they're congruent, and it's because we can map this onto this. We're not going to have to write all that. What we're going to do is we're going to support the conjecture by saying the movement it takes to get from here to here. And I've kind of given this up front that this is not one of my strong points, and unfortunately, when it's not a strong point for the teacher, sometimes it makes it not a strong point for you guys. But I'm hoping you'll overcome my weakness. But so to get from here to here, and again, not writing the lettering. So this guy points down. This guy points down this way. So you're going to reflect, and you're going to end up going across the axis. So it's going to put us over here. I'm going to do the coordinate rules, and I'm going to graph this guy, and that's why I didn't color it in. And then from there, you'll see it's just a movement to the left and down. But I wanted to do it this way. This kind of helps us a little bit. And these are level 4, level 5 questions, so this is definitely something we want to try to hit on the EOC. But again, some of these things are a little tougher. So we're going to go from the right side of the page to the left. So we're going to reflect in the y-axis. And to do that, your x comma y becomes negative x. Hang on. This is what happens when I don't watch the notes, or at least glance over. Negative x comma y. I was right, but I do this too many times to question it. All right, so we're going to, in the middle here, this is going to be our reflection. We're just going to say it reflect in the y-axis. And then below, we'll put what the movement is. This is going to be over here, though. So your x comma y, so positive 2 is going to become negative 2. 5 is going to stay the same because the y stayed the same. We took the opposite sign. These just all happen to be positive, but if one of them was negative, we'd flip it. So positive 1 becomes negative 1. That positive 1 stays the same because, again, y is the same. Positive 5 is negative 5, and then the 2 stays the same. So here's our reflection. Let me graph this for you. 2, 3, 5. Positive 2. You see one of these points, you see it's in the middle of this triangle, so if it's colored in, you can't see it. So I have learned from at least one mistake. -1, -2, +1, 2, 3, 4, 5. And then -1, +1. See, reflection, this is 1 over, this is 1 over. This is 2 over, this is 2 over. We could do it that way, but I wanted to do both so we could see the math and see the reflection. So, we reflected over here, and now you see it lines up. It's only going to go over 2, down 1. I'm going to do this in pencil so we can just prove it. And then we'll show the coordinate rule here and make sure those points line up. All right, so J, K, so this is K, J, yeah, J's here, and K's over here. So this should be Q, yep, this is N, so these are all lining up. It's P. So from J to Q, so yeah, -1, -2. So in this case, it's x comma y becomes x minus 2, y, let's see, y went over 2, x went over 2, y went down 1. So y minus 1, sorry, this is getting a little messy. Let's just double check from here. Yeah, here's the point, 1, 2, and then down 1 from here. 1, 2, and then down 1. So yes. All right, so -2 minus 2, comma 5 minus 1. Here it's -1 minus 2, comma 1 minus 1. And then -5 minus 2, comma 2 minus 1. All right, so I'm going to back up here. So -2, because we were saying we went left 2 and then down 1, which is the same. So that's -2, left 2, down 1. So -2 down 1, over 2 down 1. So our x goes -2, y goes -1. So -2 minus 2, 5 minus 1. So -2 and -2 make -4. 5 minus 1 makes 4. -1 minus 3, -1 minus 2 makes -3. 1 minus 1 is a 0. -5 and a -2 make a -7. 2 minus 1 is 1. So, and then it lines up. So it goes from where they said it was to where they said it would be. Sorry, that took a little bit longer. I hope you got something out of that. Let's flip over, because you're going to do it yourself. Hold on. Gotta fix it. There we go. So, you're going to do it yourself. However, they give you some choices. So, what you're going to do, go ahead and graph ABC in one color. I'm going to show purple. So, you're going to make ABC in purple. And then you're going to go EFG in blue. And they're asking, they want to know the side length. So you're going to use the distance formula. Distance equals the square root of y sub 2 minus y sub 1 squared plus x sub 2 minus x sub 1 squared. And you'll see it written either way. And the reason that is, so look at this plus this. 2 plus 1 is the same as 1 plus 2. As long as it's your 2's and your 1's, this is okay. But you're going to use this, and it wants you to check all the sides. I want you to check AC, BC, and FG. See if these guys are congruent or not. If they are, then you're going to be able if they're all congruent, you would say this. If the ones that are corresponding, because remember, A goes with E, B with F, C with G. So technically, AC would go with EG, not FG. So those are not, technically these are not corresponding sides. So let's just do this. Let's cut that out for you. All right, so now you're dealing with these three. So check these two sides. If they're congruent, go ahead and say side, 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 because you won't be measuring well, you can measure all three, but really it's the same thing. My definition. Yeah, really, C and D, that's kind of redundant, so I apologize for that. Excuse me. So, again, use the distance formula for BC, use it for FG. They're either congruent and it's C, or they're not and it's B. But do graph them so you can take a look. But the numbers don't lie. Don't forget that. Let's go down here to the bottom. I'm going to make it too dark. This thing is like... Alright, hold on. Okay. This guy's way tough to see. I'm going to try to color this in. May be able to see it a little better on the video than we could in class. Yeah. So it's J here, L here, K is up here. K is probably the hardest to see, and M down here. So example 3, playground equipment. Excuse me. Shown appears to be made of congruent triangles. So these are like kind of like the monkey bars, but it's a big cage, and all these are triangles. So they're saying it appears to be made of congruent triangles. So they're saying if KL, so KL is right here, and LM are congruent. So we're going to try this. KL. Yeah. All I did was LM. Maybe you can see that. Let's just do kind of like this. So maybe that's a little easier. So again, KL and LM. So here and here are congruent. And that's given. We can kind of double knock this out because it's a little aggravating when we can't see it very well. Excuse me. And it says JLK. So JLK and JLM. I have to really zoom in. But both sides of that angle are congruent. Ah, God, that's terrible. It's this side. Maybe you can even see that a little better. But it's both sides of this angle. So JLK, JLM. I hope you guys follow me enough. So that's given. So number 3, JL is congruent to JL. So this guy is with both of these triangles. And of course, I'm not even going to try to write on there. But we know that something's congruent to itself because when we look in our mirror, we see the reflection. And this is the reflexive property. All right, so we had a side, an angle, and then a side. A side, the included angle, and the side. So this would be side, angle, side. Okay, now I'm going to zoom out a little. And I'm going to draw you this picture that somehow didn't end up in the notes. I apologize. Please don't shoot the messenger. Yeah, here we go. All right, so here is your here's your drawing for here. I am going to go ahead and mark your givens. So this is a kite. Appears to be made up of congruent triangles. DE and FE are congruent. So DE and FE. And it says that EG, so this guy bisects this angle. So this guy and this guy are congruent. And they want you to prove. So we've already got an angle and a side and an angle. We need a side. This guy kind of looks, well, there you go. So you can take it from there. I am going to scooch down. All right, and so we changed the practice. We actually only did 1 through 4 because of the exit ticket. We got some extra practice, and I've got a proof thing coming, so we lowered the practice on your extra practice worksheet. It's just the 1 page instead of 2 for 5-3. All right, so in summary, should be super easy. If 3 sides of one triangle are congruent to 3 sides of another, they're congruent according to what postulate? 3 sides is like that, right? Side, 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 or SSS. This one, what conditions can be used to identify whether 2 triangles are congruent? I said early on, there are 6 corresponding parts, 3 sides, and 3 angles. And you, in order to prove, congruence, you need 3 corresponding, and I'm going to run out of room because I didn't write it, parts, which are sides and angles. All right, that's it for tonight. If you have any questions, please let me know. Until next time, have a great night. Sorry, no bonus word on this particular video, but if you are still listening and not just taking notes, next video, which it's pretty late tonight, so it'll probably be tomorrow, I will do 2 bonus words. I'm going to write that at the bottom here. So 2 bonus words. Next video. So listen out. Please like and subscribe. Let me know if you have any questions. Send me a message in Focus or on Teams, or you can comment if you are not one of my students but you need some help. Be glad to help you. Have a good night.